This video is for showing Pelco thermography camera. What you're looking at here is you're looking at the web browser of our thermography camera. Our thermography camera is completely IP based, which means that you can access the video and the web interface configuration anywhere you can have access to the internet and connection to the camera itself. There's no additional software or application that needs to be installed in order for the thermography application to work. What you're seeing over here is you're seeing the display of temperature alarms that has been configured and how it's showing up with the JPEG overlay. Before I get into more detail about how to configure the alarm overlay, let me go in and show you how easy it is to configure the temperature alarm behavior for setup. First of all, you have to find a web browser. It doesn't have to be an Internet Explorer web browser. In this version of our thermography camera, we have moved away from the necessity of having to have Pelco media player and only being able to use under Internet Explorer. By selecting the JPEG stream, the overlay will appear with the push of a button for toggling thermography overlay, or you can have a choice of a split screen if you click on this button here to open thermography in the new window. That's what I'm showing over here. The temperature behavior are separated by the three behavior that we have. One is absolute threshold, the other one is relative threshold, and the third one is self-reference. It shows the temperature behavior that's selected by the user and the temperature reading of that behavior, along with the status of each of the zone. If the alarm has been triggered, the zone itself will appear to be red color and the status will show alarm. If you are interested in seeing the temperature for each zone, you can also move your mouse over each zone to see the temperature inside that zone. Those are the new improvements that we have added for our thermography camera. For configuration, if you click on settings, it will then take you a page where you can see a tab on the top. It says event, and you can go into analytics configuration. By doing so, you are at the configuration page for our different temperature alarm behaviors. The first behavior that we have is called absolute threshold. This is for the use case if what you are interested at is triggering an alarm at absolute temperature. You know what that temperature is. In this example right here, I have chosen to trigger the alarm at greater than 30 degrees C. The behavior that you can choose for the zone is either maximum, minimum, or average. The idea for this is to make it easy for the user to use. Our whole idea around designing the camera is to make everything easier for the user to use. For the drawing options, we can simply drag and drop a box around the subject of interest. And when we do that, instead of having to require the user to draw a very definite shape of the alarm zone, we are trying to make it for the user to include, and by saying that by drawing a square we may have some background and foreground information. Our algorithm will automatically separate the background with the foreground information by the user being able to select if the behavior is maximum, minimum, or average. Maximum meaning that the object inside the region of interest is higher temperature than the background. Minimum means that the temperature behavior, the temperature of the object inside the region of interest is lower than the background, where average means that you are able to set up a zone that's smaller than the object of interest itself. In this case, I have set up the box over here to include some of the background and the object of interest, and my object of interest in this case is a lamp that's hotter than the background. In this case, I want the alarm to be triggered when the maximum temperature that's inside the zone, in this case is the lamp, to be greater than 30 degrees C. And then we can also rename the zone to be something a little more meaningful. In this case, I'm going to call it Absolute Zone 1. And by activating behavior and saving it, I have created my first zone. And by adding zone, it's as simple as just drag and drop. And that's the first behavior. We could also choose to have the temperature alarm against something gets lower than a certain temperature, and that behavior is set up by selecting the greater than and less than of a temperature threshold. Okay, and the second type of behavior that we have is called a relative zone. The idea of relative zone is very simple. The use case of relative zone is if you are monitoring two pieces or multiple pieces of equipment in the same group, and they are supposed to be similar in temperature. One use case is monitoring bushing cap in an electrical substation. If the temperature range of all the zones has become greater than a certain threshold, a certain amount, then an alarm will trigger. The idea is that for all the equipment that are similar in temperature, they can all rise and lower at the same time. But it's not okay for some piece of the equipment not rising or not lowering to create a large temperature delta between them. We use the idea of having different groups. So multiple groups can be set up to have multiple zones, and the zones being compared inside the same group can be set up to throw an alarm. The same idea applies of selecting maximum, minimum, or average. And by being able to draw a zone that's bigger than the subject itself, it really allows the user, first of all, of not having to control with a very complicated drawing tool. And second of all, if the camera starts shaking or the object starts moving in an outdoor configuration, we don't really have to worry about the object going in and out of the alarm zone and triggering a lot of false alarm. In this case right here, for the relative mode, you can see that we have a delta temperature that's greater than 5 degrees C that will trigger an alarm, or if it's less than 0 degrees C, it will trigger an alarm. This is to provide a range of baseline. And then this is the third case. The third case is what we call a self-reference mode. The idea behind the self-reference mode is that the user may be under a condition where he or she does not know what the exact temperature is. So the user does not necessarily know how to set up the absolute temperature for the alarm. But what the user does know is that the current temperature inside that zone is what we will consider normal. And if the temperature has rise by a certain amount above a threshold or lower by a certain amount below a threshold, then we will trigger an alarm. In this case right here, I've set that delta to be 5 degrees C. Something that we have also done to make it user-friendly is we use the idea of global settings. Let's take a look at that. What's inside global settings is we have a place where a weather station IP can be entered. Our camera works with a specific weather station controller that it will request for different type of weather conditions. In this case, I do have a weather station set up, so let me go ahead and type that in. And by clicking on Enable Weather Station, then it allows the camera now starting to query information from the weather station. One thing that's making temperature accurate in outdoor condition is the information of what the ambient temperature is like, what the relative humidity is like, what the atmospheric pressure is like, what is the distance to the camera, and what is the emissivity of the material that we're looking at. When this information, when the weather station is not available, all this information are required entered by hand, which is very cumbersome, because you can imagine that temperature changes during the day, during the night, and humidity also changes during the summer, during the winter, and everything. By having the weather station to report all this information, it removes the user by really have a deep understanding of what each parameter is about, and having equipments to be able to measure those values in order to maintain accuracy. The distance to the subject, if that's all the same for everything that we are looking at that's inside a camera for each zone, then we can use a global setting over here, so the user does not need to individually configure it. Or the user can override that by unchecking the box inside zone settings and typing the distance to the subject that you are monitoring. Another thing we have included is an emissivity table. Emissivity is the idea of how much energy that can be transmitted from the material of the subject that we are looking at. You can think of this example right here, 0.96 as 96%. That means the material that we're looking at has 96% of efficiency of transmitting its own energy, and it reflects by about 4%. It is much easier to measure temperature with a material that has high emissivity. When the emissivity is low, the temperature is harder to measure, because then the reflectivity is high from other objects that could be reflecting. By selecting a material that's inside the list, the emissivity automatically updates to the correct number without having the user to look up what the emissivity of the material is, also not requiring the user to have an understanding of what emissivity is about. Then again, for advanced users who knows what the emissivity of the material is, he or she can choose to type in the number of emissivity. This is from showing what I have done here. This then finished the basic configuration of our analytics setup for temperature alarms. Clicking back to the live view, you can now see the main page where I have the zone set up with different behaviors. And if I move my lamp, you can see the alarm triggering. One thing that's also good with our camera is not permanently embedding the temperature information that's overlaid onto the video that you're seeing. That's why we're able to turn it on and off. We're using temperature metadata, which is information that can be received separately by a third-party application. In this case right here, I can also choose to close my video window and just leave the separate window up for looking at different temperatures and which one has triggered an alarm. This is particularly useful for applications like temperature trending and being able to see if a certain object has different temperature behaviors during different time of the day or different time of the year. Next, let me show you milestone. Because of the capability of having the metadata configuration and metadata information transmitting through our camera, that makes our milestone integration particularly easy. We have a third-party application plugin that's developed purely just for our thermography camera. Once the plugin has installed, we can click on adding the camera over here, which I have already done. And inside the plugin, by adding the camera itself, you can then choose to configure camera behavior in different ways. Let me show you what we can do with this. Over here, you can see the configuration page comes up with different temperature behaviors. We have made it in a way where an alarm doesn't have to trigger in order for the configuration to be entered. The user also does not need to manually enter each of the configuration, although the user can do that. By clicking on Start Scan, each of the behavior automatically populates. By setting up milestone with different analytics event behavior, we can then type in those analytics behaviors into the column over here. We could then select different color associated with different behavior, and also the location of where the behavior and temperature would show up when we view it through a client software. This is particularly useful if your subject of interest is occupying some region of the image that you don't want to have the temperature information blocking the view. In this case, just as an example, I put 4 different regions in 4 different corners. Now let me go into the client software and let's take a look at what it looks like. This is a Milestone Smart Client software. By finishing those configuration there, you can now see that with Milestone Live View screen, we now show the temperature boxes, which is not available with typical Milestone software. You can also see that when the alarm has been triggered, there is a triangle shape exclamation mark to show that that particular alarm has triggered. And it will also show the same shape of triangle next to the temperature information for that particular zone. You can also see that over here we have the temperature of the current zone and the behavior the user has selected. The up arrow in this case means maximum behavior, and I have chosen to put the 4 temperature behavior at 4 different corners and of the color that I selected previously. There is also a button over here to toggle the overlay on and off. And the reason that we can do this is because this information is actually coming through metadata, and Milestone plugin is handling the drawing of the zones by using the metadata information. Now let's look at playback. In the playback information over here, a user can choose to play back any frame that they want, and being able to show the temperature information, temperature monitoring information, along with alarm information. In this case over here, you can see that when the alarm is being played back, when the video is being played back, you see the temperature behavior being recorded, and you can also see the alarm being recorded. Again, this has an overlay button that you can turn on and off to display or not display that information. Now let's look at the alarm manager. One thing that we have also implemented is for Milestone to be able to read the temperature alarm through our metadata. By allowing that capability, you can see below, you can visually see without the video frame, without clicking through to look at the video frame, of what temperature has triggered an alarm with what behavior. In this case right here, you can see this is 26.8 degrees that triggered an alarm for a relative zone. Where over here you can see that the absolute zone has triggered an alarm at 41 degrees C. So it's very easy to look and very easy to go through the video to later on, at a later time, to examine what behavior has triggered an alarm and what was the cause of the alarm through our Milestone integration. So this concludes my presentation. The goal of our camera is we try to make everything easy to integrate, easy to use, and we will further improve the application integration for other type of VMS system. Thank you very much.